Duplicates and external controls are two of the four pillars of any good quality control process. They look very similar, but their objectives are very different. Hello, welcome to Golden Droplets episode number 38. My name is Ricardo Valls. I am the founder of Value Consultant, and in today's episode, we will be discussing duplicates and external controls. How to take it, how to study it, and what to do with the results. So, once again, Golden Droplets, episode 38. Enjoy. There are different types of duplicates, like field duplicates, lab duplicates, but we are going to be talking today mostly about the lab duplicates. So these are the samples that when they're taken in the field, they are split in two, and one is the original and the other one is the duplicate. I have been shown in other videos a very simple way to do a proper mixing of the sample using a plastic bag and two persons. We put the material in the center of the bag, and then we start pulling up the two corners of the bag one at a time, so the material will roll over, and then roll back. And you do that several times, and then you do the quarting. Half of the sample will be the original sample, the other half will be the duplicate. We usually take a duplicate every 20 samples, more or less, except when we are dealing with gold. Because of the nugget effect and the fact that there is literally very little that we can do when duplicates fail, I recommend to use duplicate for gold exploration only one every 40 samples. Okay, so what else? So let's talk now about how to test the validity of a duplicate. And in this case, we do not compare sample to sample. This is one of these cases when we need to use statistical methods, basically the student and Fisher criteria. So we're going to have one column with all the original data and a second column with the duplicates. And our objective is to determine if these two columns of data are analogous enough. For that, the mean and the standard deviation should be similar. So here, by the way, you can download this table here. There is a link from my Mendeley database. Okay, so if we go to duplicate controls, this is an example where we have, I think, 100 samples. Yes, 100 samples. And you have the original value and the duplicates. Then it determines the part that are in green, light green, this part here. These are the data that you can and should enter. And the program will automatically detect the mean and the standard deviation, and applying the student and criteria and Fisher criteria test, they will tell you if the values are compatible or not. If they are not, if one of these two tests fail, then your duplicate fails. So what to do in the case of a duplicate when it fails? Well, as I mentioned before, there is very little that we can do. We always need to tell the lab, okay? So, you know, there is some problem with the duplicates, take a look, blah, blah, blah. They may want to repeat the duplicates that fail the most. That's okay. But usually what you will do is just take the average of the two values and use that as your data. Okay, so that is what you do with the duplicate. You need to determine the analogy of the mean and the standard deviation, and using the student and Fisher criteria, you determine if the values are analogous or not. If they are, okay. If they are not, as I said, you need first to inform the lab. And then maybe, for example, in the case of soil sampling, you may want to increase the amount, the weight of the sample. You were taking, for example, 200 grams, take 300 or 400, because it's a known fact that the more material you have, well, the less will be the nugget effect. It's not a guarantee. And for example, when you're doing diamond drilling program, you are fixed, you are constrained to sample only half of the core. So that's not something that you can change there. In the case of the duplicates from the core, again, there is another video in my Golden Droplet series where I explain that the best way to do the duplicate from a core is not to take the half of the core and split it in half, 1/4 for the lab, 1/4 for the as a sample. The best way is to crush the whole material and then use a splitter. And that way you will get a good duplicate from the sample. Okay, so that is all with respect to the duplicate. And as I said, the duplicate is a way of controlling the reproducibility of your data. This is very, very important, and that's why we use it all the time. The next step will be the external control, and this is usually done at the end of a program. It may be a soil sampling program or a drilling program. Again, it's at the end, and we work with the pulps. Okay, so usually we take 1% of all the sampling. Let's say, for example, you take one sample every 100 of the pulps, and you send this pulp to a better lab, a lab that is usually called arbitrage, because they are the best at determining the results. Usually SGS is used as the lab for external controls. So in this case, we are not going to try to figure out if our results are comparable, are analogous to the one of the lab. During the external control, our objective is to determine first if there is a systematic error in our data, and then if there is a casual error in our data. Worst case scenario, if there is a casual error in your data, there is nothing that you can do. Your data don't have the necessary quality to support a resource estimation, and you will be forced to send all your samples to another lab that has a better technology or works better. Okay, so this happens when you're trying to use a non-certified laboratory just to try to save some money. In some cases, it's okay, but in many cases, you're just trying to grab the cat by the tail, and it's not a cat, it's a tiger. Geology is not gentle with people that try to save money, so don't do it. Use a good lab. It doesn't need to be one of the 3-4 top, but it must be a certified lab. Because at the end, as I said, if you send your samples to a lab for external control and you get a casual error, all your data is lost. You cannot do nothing with that. Now, systematic errors. These are errors that can be fixed, and that's not a big deal. You can adjust, and I will show you how to do it. One thing that is very important when you send your pulps to the lab, external lab, they need to use the same technology that your original lab used. So the same way of dissolving the sample, the same technique for getting the result. You cannot compare, you use your lab to do, I don't know, ICP-MS, and then you send it to an external lab and they are using INA. No, they need to use exactly the same technique used by original lab and the same extraction method, the preparation of the sample, the extraction of the metals from the pulp should be the same. So if your lab use 3-acid, this external lab need to use 3-acid method. So in this table, and again, I have it here for 100, you can of course insert more columns if needed, or delete. You don't need to delete, you just put the data that you have, and you're only going to enter the data for the X-basic and X-controller. That is your lab and the external lab. And the program will automatically calculate the systematic error, okay? And the casual error too. So there is a systematic error here, okay? But there is no casual error. So what the program will do is will take that systematic error out of your data, okay? That is the same thing that happens when, for example, a topographer is doing a map, and when they're going to close to the last point, there is a little difference. They take that difference and deduct it from all the points, so the polygon will close. This is the same thing done here. In this column here, the systematic error of our data has been eliminated, and the test for casual error is done again, and your data is okay now. So that means that, well, okay, your data is correct, but it also is telling you that there is a systematic error. So you need to correct your original data because you have a systematic error. In this case, your data are a little bit bigger than what they should be. And for that, we use the last tab in this program, which is basically a regression analysis in which you put your basic and your control, and the program will give you immediately what will be the formula that you need to use in order to convert all your original data into this corrected one. And in this case, would be 1.49 plus 0.49 multiplied by the control value. Okay, so that way you will correct all your original data, and now your data is ready to be used as or for resource estimation or whatever other process you want to do. So that's it. That is the difference between a duplicate, which is when you're trying to check the reproducibility of your own data in your own lab, and the external control, where you want to determine if there is any systematic error, eliminate it, and if there is a casual error. Once you do that, once you have eliminated your casual error, then you can use a formula, a regression analysis, to convert all your original data to the new corrected data set. And with this corrected data set, you can do all your processing. I want to mention that this subject was brought up by a geologist from one of my groups that asked, well, how do I do the external control thing? So here it is, not only external control, also duplicate the difference between the two of them. And if any of you have a question, a practical question, how to or how I solve something, write to me. I put my Gmail in the screen. And with that, I wish you all a very good day. Until next time, bye-bye.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.